Once again, finding the minimum completion time. We've got a community centre being built. 9 activities have been identified. What is the critical path and minimum time in weeks to complete this project? All right, so we're looking for the ones with 0 float times. All right, we have a 0 float time there. We have 0 float time there. So we're going activity B and then activity C, and then 0 float time for activity F, then 0 float time for activity H, and then I. So we have a activity thing of B, C, F, H, I, and it is it weeks? Yep, weeks. And the completion time is 19 weeks. Okay, so I'll leave the critical path there so we can see it. The builders of the community centre are able to speed up the project. Activities A, C, F, and G can be reduced in time at an additional cost. Which of these activities, if reduced in time individually, would not result in an earlier completion of the project? So what we're looking at is if I change A, C, F, or G, which one of these would not help? So what you've got to look at is, okay, which ones are not on the critical path? Because the critical path is the one that's going to change things. So if you have a look, which of these two activities, so it's more than one, activity A is not on the critical path. Activity D is not on the critical path. Activity G is not on the critical path. And activity E. Where's E? Oh, there. E. So those 4 are ones that even if you change them, it wouldn't affect it. So which are the ones that would not result in a thing? So A and G. F is on the critical path, C is on the critical path. So A and G are the ones that would not result in an earlier completion of the task. Right. Activity C. The owner of the estate is prepared to pay an additional cost to achieve early completion. The cost of reducing the time is $5,000 per week. The maximum reduction in time for each of the 5 activities, A, C, F, and G, is 2 weeks. So the maximum you can spend is 10 grand on each one. Find the minimum time in weeks for the project to be completed, given these activities are reduced in time. All right, so let's have a look. We're going to reduce all of them, all of those ones, A, C, F, and G, and we're going to see if that changes our critical path. So I'm going to unhighlight the critical path now, and we will go through and have a look. So A, we're going to change from 4, we're going to change that to a 2. Activity C, we're going to change that from a 3 to a 1. Activity F is now going to become a 2, and activity G is now going to become a 1. Okay, so we've reduced them all by 2 weeks. So let's see what happens. We have to do our forward scan again. So that's going to become a 2, and then D is going to become a 3. And then where are we now? Let's have a look. B is still going to be a 4. This is going to be, should I cross them out or not? Yeah, I'll cross them out just so I can see it. That is now going to become a 5. And this here, where is it? That one there is now going to become, well, what's it going to become? What else did we reduce? Oh, C. I forgot to reduce C. Oh, no, there it is. So B is 4, C is still 4. Yep, that's correct. Gets a bit confusing when you've got it all written out and you can't just erase it all, but that's all right. I'm going to just scribble that and make it so that I can kind of not see those numbers, so I'm not thinking about those previous numbers. All right. So B is 4. Now, if I go across this way, I've got 4 and 4. That is now 8 because we've got from activity B, which is 4, activity E, which is 4, which gives you the 8. So that I need to change. No, that stays at All right. So that's E and C. I don't like it when they put them all in the same spot, but that's okay. They both started at 4, both at E and C. So because, well, that looks like it's an 18. 8. Because activity E, this one is now going to, because that's an 8 there, and activity H is a 2, that's going to become a 10, even though we've got the 5 with the activity 2, and that should be a 7, we've got to be stuck with the activity 10. And so what you're actually seeing is all of a sudden the float times are going to change. So we've got I is that, is 6, so we've got 16 there. So I think we have changed all of them thus far. So this will now become 16. Then we come back, that will become 10. So you can see that's still on our critical path. Now, if you have a look, if we come back, we've got from 10, that will come back to 8. This, however, will come back. We take from the 8, we take the 2, and we get to 6. So we now have that as our critical path. That one, when we take the 1 off, we're going to end up at, what have we got? 7, because we're coming back from 8 minus the 1 will give us 7. We come back here, we've got 4 coming off the E, so that actually becomes a 4. And the C actually doesn't become that, because we're coming back from 6 minus the 1, that actually becomes a 5. So you can see E now becomes the critical path, not C. And then taking the 4 off, we still get back to 0 that way. So realistically, that is now our critical path. We're going on B, E, H, I is now our critical path. The other thing to note is that even though we could take 2 weeks off A and 2 weeks off G, because they're not on the critical path, it doesn't actually help us. So rather than doing that, we will not take it off, and that way we can save that money. So we didn't have to pay for A and G to come off. C and F, we took them off, and it did change our path. But taking off A and G did not. Yeah. Cool.